Welcome back to the deep dive, where we drill down into specialized sources to pull out those knowledge nuggets that are applicable everywhere. Sometimes we're analyzing global economics, sometimes historical turning points. Today, it's something incredibly, and I have to say, satisfyingly specific.
We are really getting down to the brass tacks of highly localized risk management here.
Absolutely. Our source material today is a single laser-focused document. It's a detailed toolbox talk, and it's dedicated entirely to one task.
Just one.
Manual panel shifting on staircases. Think heavy, flat, awkward, and on an incline.
And that's really the intellectual opportunity, isn't it? Our mission isn't just to learn how to move, say, a drywall panel.
No.
It's to perform a kind of academic reverse engineering of an expert-level risk assessment. When you look at a problem this defined, you extract the knowledge about the why.
Why behind the rules.
Exactly. The core critical thinking that generates these really stringent rules, and that deep thinking, well, it applies to any complex lifting operation you might face.
What's great is the structure. We have this comprehensive list. 10 highly specific hazards.
Right.
Followed by 16 distinct control measures designed to mitigate them. It's a masterclass in anticipating failure.
Across multiple dimensions, too. Physics, logistics, and just plain human error.
So let's start breaking down their threat assessment.
Let's do it.
Okay, let's start where any good safety assessment begins. The immediate, most common physical hazards. These are the risks for moving any heavy object by hand.
The obvious ones.
Right. The document lists the basics first. Muscle strain, back injury, shoulder injury. Just pure physical strain from the effort.
Right. The simple biomechanical stressors are always the foundation. Then you have the basic kinetic risks, the accidental failure.
Like dropping it.
Exactly. Loss of grip, which leads to dropping the panel, or a misstep, slipping on the staircase or tripping over something.
That's the stuff everyone thinks about when you hear manual lifting accident.
For sure. But the real insight, the real deep thinking, comes when the assessment starts drilling down into the specific geometry and the environment of the staircase itself.
This is where it gets interesting.
Yeah, this is where the risk moves beyond general lifting and becomes unique to this exact scenario.
So it's a shift from general risk management to something highly specialized.
That's it. You have to really picture the conditions. You're carrying this large, heavy, flat object on a constant incline.
Right.
And you're constrained. You've got a wall on one side, a railing on the other, and the source identifies the specific danger of hands caught between the panel and the railing or walls.
That's a crucial distinction. It's not just getting your hand smashed by the weight of the panel falling down.
No, it's different.
It's the huge surface area of that panel becoming a lever, right? It pins your hand against an immovable surface.
An unforgiving surface. It's a pinch point hazard created by the environment itself.
Wow.
Exactly. And they draw another critical physical distinction. They separate the hazard of dropping the panel from the hazard of the panel slipping and crushing feet or hands.
Dropping versus slipping. They sound similar, but I'm guessing they're not.
Not at all. Dropping implies a vertical impact. It's mostly just impact force. Slipping, though, that implies a loss of control, where the panel slides down the incline.
And a sliding panel introduces new dangers, doesn't it?
Absolutely. A drop is an impact. A slip, on an incline, introduces significant shear and friction forces. The panel becomes a massive sled.
Oh, I see.
It can shear an appendage against a step edge or introduce different types of crushing injuries because the force is moving diagonally down, not just straight down.
So the injury profile is fundamentally different.
And you could argue much worse than a simple fall.
It's fascinating that they isolate that difference. It really shows how deeply they've modeled the potential failure.
It does. And beyond the physics, they move into the people and systems failures. The source lists the difficulty of turning in narrow staircases, a basic logistical hazard, and then it zeroes in on team dynamics.
Let me guess. Communication.
You got it. The two big ones. Poor coordination, leading to sudden load shifts, and miscommunication, causing a complete loss of control.
You can have perfect technique, but if one person stumbles or doesn't hear stop,
The load shifts instantly, violently, and that sudden unexpected rebalancing is what typically causes catastrophic failure. The team just can't react predictably anymore.
it's clear that safety here is less about, just preventing muscle strain and more about meticulously managing geometry, momentum, and team sync in this tight space.
It's a testament to how complex a simple task can become when you confine it.
So we've mapped out the dangers. Now let's move to the battle plan. The prevention has to be just as meticulous.
It
The
does.
source outlines 16 controls, and the first few are all about preparation before the panel's even lifted an inch. This isn't just lift carefully.
No, this is strategic management. And control measure number 1 is the fundamental requirement. Conduct a load assessment.
What does that entail?
The source mandates checking 3 specific things: the weight, the size, and most importantly, the center of gravity, the CG.
We talk a lot about good technique, but this document seems obsessed with the center of gravity. Is the geometry here really more dangerous than the sheer weight itself?
The geometry makes the weight dangerous. On a flat floor, the CG is stable, or at least it's predictable.
Right.
On a staircase, the whole system is on an incline, and that CG shifts dynamically relative to where the lifters are on the steps.
So if the CG is miscalculated.
Even slightly, the entire load distribution becomes unbalanced. One person might suddenly be taking 80% of the weight instead of 50.
And that creates the organizational hazard we just talked about.
Yeah.
The unexpected load shift that breaks the team's control.
Precisely. Miscalculating the CG is the tripwire for nearly every other system failure, from fatigue to loss of grip. It is the single most critical stability factor on an incline.
Okay, so assess the physics of the load first. Then I assume we assess the environment.
The pre-planning continues with the staircase assessment. You have to assess the width for maneuverability, and critically, its structural load capacity.
You have to know if the stairs can even handle the weight.
The combined weight of the panel and the team carrying it, this is basic structural safety.
And they don't leave manpower up to chance either. The plan requires using adequate manpower and a pre-planned route with adequate space.
And it's not optional. It's a mandatory strategic control. If you don't have enough people or the route is too complex, you don't start, period.
And what ties all this planning together?
The final mandated communication step. Conduct a pre-task briefing, the toolbox talk, the TBT.
The huddle.
Exactly. It's the mandatory huddle where all those assessments, the CG calculations, the route path, the manpower distribution are communicated to every single team member.
So planning isn't complete until everyone knows the plan.
And their role in it. It's designed to remove the hazard of miscommunication entirely.
So we've done the planning. The team is briefed. They understand the physics. Now let's look at the actual engagement. What happens when hands are on the load?
Right, the execution discipline.
This section seems to focus heavily on the human element, training and technique.
It does. And the required training level is the first physical control. The source is clear. The personnel must be assigned with proper manual handling training.
This is not a job for the new guy.
No, this requires trained professionals who understand load dynamics.
And that training feeds directly into the physical execution. They must use proper lifting techniques, back straight, bend knees, and do a synchronized team lift. Now that sounds basic, but why is that straight back technique so crucial on a staircase specifically?
Because the natural human instinct on an incline is to compromise your posture for a better grip or a better view.
You lean forward.
You lean forward, you twist. The rule demands that the fundamental biomechanical safety keeping a neutral spine cannot be sacrificed, even for the awkward geometry.
And that prevents muscle strain.
It prevents the immediate muscle strain hazards, yes, but it also keeps the lifters structurally aligned to better handle those sudden load shifts we talked about.
Okay, that makes sense. Beyond technique, we look at equipping the team correctly. The PPE, the personal protective equipment, is very specific.
It is. It's tackling both slipping and loss of grip hazards at the same time.
So anti-slip safety shoes, obviously.
Direct engineering control against slipping. But critically, they also mandate using resistance gloves with good grip.
That specific detail with good grip seems vital. You can protect hands from getting scraped, but if the gloves are slick, you've just made things worse.
You've increased the hazard of dropping the panel. The material property of the glove is just as important as any padding. It has to guarantee a better purchase on the load.
So the gear choice connects directly back to the physical nature of the task.
Absolutely. And because this is strenuous work, the document incorporates a fatigue control.
Rest breaks.
A requirement to plan intermediate rest points. Fatigue causes sloppy technique, it leads to loss of visual contact, and it increases the likelihood of those accidental load shifts.
So planning rests proactively mitigates that human degradation.
That's it. Every piece of gear, every instruction is designed to counteract one of those initial 10 failure points. It's an integrated system of defense.
And that brings us to our final set of controls, which focus on external factors and the crucial internal communication.
Right. The best trained team can still fail if the environment is hostile or the communication chain breaks down.
What stands out here are the clear, simple, actionable steps for prepping the space. Keep the staircase clean, dry, and well lit, and remove all obstructions.
This is just fundamental risk elimination. You get rid of tripping hazards before you even start. If the stairs are wet, your anti-slip shoes are less effective.
If they're dark.
Visual contact and route planning just break down. You have to control the environment aggressively.
And speaking of contact, the communication protocols are really detailed. Maintain clear communication is standard, but the specific requirement to maintain visual contact adds another layer.
Visual contact is a critical backup to verbal commands. It's especially important if the team is spread out on a long flight of stairs, or when navigating a tight corner that might create echoes.
It confirms coordination instantly.
It does. But the most, I think, counterintuitive and insightful control is about the specific assignment of roles.
You mean the guide role?
Exactly. They require the team to assign a person solely to signal and guide the movement.
And this is the non-negotiable part that removes the hazard of divided attention.
Yes, the guide is not burdened by the load, which means their sole focus is external. Watching clearances, watching the team's balance, communicating changes.
They're the external nervous system for the whole operation.
That's it, completely focused on safety and synchronization.
That dedication of resources is a major commitment to safety. And then we hit that final, very nuanced instruction about team size.
Use smaller teams in confined staircases to prevent crowding.
This seems to go against instinct, right? Heavy panel, you'd think more people.
You would. But the source explicitly identifies maximizing manpower as a danger in a confined space.
Why is that? Is it that coordination complexity outweighs brute strength when space is limited?
Precisely. Crowding means people trip over each other. They can't execute that proper straight-back technique. They block the line of sight for the guide.
And they reduce the space needed for critical maneuvers, like turning the panel.
In a highly confined space, discipline and coordination are far more valuable than raw muscle mass. The goal shifts from merely lifting the weight to controlling the weight's movement.
So this whole deep dive into one safety document really showed us two major categories of protection. First, there's the meticulous pre-assessment. Knowing the center of gravity shift, knowing the structural capacity of the stairs, and briefing everyone with that toolbox talk.
And second, it's the disciplined team execution, combining the right physical controls like anti-slip PPE and rest points with non-negotiable operational controls like constant visual confirmation and assigning that dedicated load-free guide. It's a complete systems approach.
It showed that true specialized safety relies on anticipating these specific environmental failures, like the critical difference between a panel dropping and a panel sliding.
Yeah, the impact versus the sheer force.
And then establishing protocols that proactively address the specific geometry of that hazard.
And for you, the learner, consider that specific counterintuitive control we just talked about. When you're dealing with extremely heavy objects in confined environments that limit movement, like a narrow, twisting staircase, the definitive safety solution is the explicit choice to use smaller, highly synchronized teams over just maximizing manpower.
So coordination over brute force.
The takeaway is that often, optimizing coordination and spatial efficiency is the safest and most effective solution. It trumps brute strength when the environment closes in. And that principle, well, that holds true whether you're moving equipment or managing a complex, tight deadline project.